Okay, my name is Mike Toscano, and we're going to graph rational functions. We're going to start with the problem x plus 4 over x squared minus 5. And the first step to graphing it would be to find the y-intercept, which you would plug in 0 to all the x's. So you're going to have 0 plus 4 over 0 squared minus 5. And that's going to end up being negative 4 over 5, the y-intercept. The x-intercept is the next step. In order to find that, you set the numerator of the equation equal to 0. So x plus 4 equals 0, and that's going to end up being x equals negative 4. The third step, you need to find the horizontal asymptote. And in order to do that, you have to find the limit of x to infinity, and you have to take the two exponents of the highest value, so that would be x over x squared, and that would be 1 over x, which in terms equals 0. The fourth step, you need to find the end behavior of the graph, and in order to do that, you have to find the limit of x is x to the plus or minus of infinity, and that would equal 0 from the previous part of the problem. The next step would to be find the vertical asymptote, and in order to do that, you have to take the denominator and set it equal to 0. So we're going to have x squared is going to equal to 5, so x equals plus or minus radical 5. The sixth step is to find the intermediate behavior. Intermediate behavior. In order to do that, you have to do, we'll do it down here, the limit of x to positive radical 5 to the right of the asymptote, and that is going to be equal to, it's going to have a positive on the top when you plug radical 5 into the problem for x, so the original problem. The top is going to turn out to be positive, as is the bottom, so that's going to be a positive infinity, which means the right side of the graph will be going upward. The limit of x to positive radical 5 to the left of the asymptote is going to turn out to be a positive on the top when you plug it in to the original equation, and a negative on the bottom. What? And that's going to turn out to be a negative infinity, so it's going to go to the